For this video, we're going to be finding the trapezoidal sum of f of x equals x squared plus 1 from x equals -1 to x equals 2 with a delta x of 1/2. So the trapezoidal sum actually estimates the area under the curve using trapezoids instead of rectangles. So the first part starts the same. So we have a start point, an end point, and a change in x to look at. So we're going to start at -1 and go to 2 with the delta x of 0.5. So I'm cutting these intervals in half. So for the trapezoidal sum, you're actually going to be having this as the height of your trapezoid, and we're going to go all the way up to the function at both the beginning and the end of each interval. So these are the two parallel bases, and then the other side of the trapezoid that's not parallel with this will be connecting those two function heights. So you'll see that this sum follows the curve better than the left hand or the right hand or the midpoint did. It looks a lot more similar to the function itself. So we'll go up and then all the way up for this one. And we have the sum of these trapezoids. And again, they look like they're on their side. The height is actually the base of one of those rectangles before. So I wanted to take you through the steps of the trapezoidal rule. So I know that we can find the heights and we can do this, but for the trapezoidal rule, you don't actually find the area of each individual trapezoid and then add them up, although you could. Instead, basically, it's an algebraic simplification of that process. So what you do is you look at the individual bases. This right here is, I'm going to call it b sub 1. This one right here, that height will be b sub 2. This one b sub 3. This height here is b sub 4. B sub 5. B sub 6. And b sub 7. So the area of the trapezoid we know is the average of the two bases times the height. So some people write as 1/2 b sub 1 plus b sub 2 times the height, or b sub 1 plus b sub 2 over 2 times the height, etc. That's the area of one individual trapezoid, which you can do. The height of each one of these is this distance right here, which for this problem is 1/2. But what I'm going to do is actually use this idea with these bases and know that each one of these, the trapezoidal rule only works when the heights are the same, when you divide it up into equal subintervals. So my first trapezoid would be the 1/2 b sub 1 plus b sub 2 times the height. My second trapezoid would be 1/2, and you can see that it's bound on either side by b sub 2 and b sub 3. Times the same height, plus 1/2. For my third trapezoid, I have b sub 3 plus b sub 4, plus 1/2. For my next one, times the height, that's an h. I have b sub 4 plus b sub 5 times my height, plus 1/2 b sub 5 plus b sub 6 times the height, plus 1/2, and then my final trapezoid, b sub 6 plus b sub 7 times the height. Now that's 1, 2, 3, 4, 5, 6 trapezoids, but you'll see that there are b sub 1 through b sub 7, so don't be surprised when you see that's 1, 2, 3, 4, 5, 6. Now if you look at this, we can say each trapezoid represents really just one term, and each term has two things that are in common, the half and the h. So I'm going to factor out 1/2 h and look at what's left. For this first term, I'm left with a b sub 1 plus b sub 2. For the next term, I'm left with a b sub 2 plus b sub 3. For the next term, it's a b sub 3 and a b sub 4 plus a b sub 4 plus b sub 5, and you can see the pattern that's being created, plus b sub 5 plus b sub 6, and then for the last one, plus b sub 6 plus b sub 7. And you can see that all of these bases are repeated except for the first and the last. So this will equal 1/2 times the height, b sub 1 plus 2b sub 2 plus 2b sub 3 plus 2b sub 4 plus 2b sub 5 plus 2b sub 6 plus 1b sub 7. So this is specific to this one that has 6 different trapezoids. The trapezoidal rule will go to n trapezoids, and you'd go up to 1b sub n. But this is the rule that will actually make evaluating much faster. You find your function heights, which we've done this one multiple times on other examples, but this would be a 1/2, and then our height is also a 1/2. The b sub 1 was the height when x equals -1. If you plug it into the function, evaluate the function at -1. -1 squared is 1 plus 1 is 2. Plus 2 times our next height, which was a 1.25. Plus 2 times our next height, which was at x equals 0, which is a height of 1. Plus 2 times our next height, which is again 1.25. It's symmetric. Plus 2 times, and our height at 1 was exactly 2. Plus 2 times 3.25, and our final height was plus 1 times, and this height is 5. And when you add all of that up together, multiply it by the combined 1/4, you would get the trapezoidal sum, the trapezoidal estimate for area underneath that function.